This will be our test 1 review for college algebra. I'm going to call it the key because it's going to have the answers on it. 16 to the 3/2 power. This 1/2 power. What does this 1/2 power mean? This 1/2 power means the square root. All right? Square root. So I'm going to come down here and put the square root of 16, but then I also have to have this 3, so I'm going to put it in parentheses to the 3rd power. So 16, square root of 16, and then to the 3rd power. You can do 16 to the 3rd power and then take the square root, but good luck on 16 to the 3rd power. I mean, you have a calculator, I guess, but it gets really big. So I'm going to make it smaller first. Square root of 16 is 4, and then raise it to the 3rd power. Don't forget to bring that 3, the exponent 3 down. 4 to the 3rd power, 4 times 4 is 16, and then times another 4 is 64, right? 64. That's also on your list of perfect cubes in the factoring handout on the SOPs page. So it's something you need to familiarize yourself with, those perfect cubes, and make sure you can recall those things relatively quickly to save yourself time on the test. The cube root of -8. If it's an odd root of a negative, it's okay. It means the answer is going to be negative. So the cube root of 8 is 2. 2 times 2 times 2 is 8. But what gives you -8? Well, -2 times -2, that gives you a +4, and then times another -2 is is -8 indeed. So -2 cubed, or the cube root of -8 is -2. So -2. The square root of 256 on the difference of squares page, I have the perfect squares up to 25. This here happens to be 16. You just need to know it's 16, be able to find that quickly. Recall that. Square root of 16. So our square root of 256 is 16. I'm sorry, not the square root of 16. We already applied the square root to 256. The answer is just 16. No square root on the 16. 144 to the 1/2 power. This 1/2 power means square root. So then we're going to take the square root of 144, which is, that's right, 12. 12 is the square root of 144. The next one is just a parenthesis that is to the 1/2 power, which means take the square root of what's inside. What's inside is a fraction. So we're going to take this and take the square root of 169 over 81. And that also just means take the square root of 169 over the square root of 81. The square root of 169, again, off that list, 13. 81, you should know from your times tables, is 9. 13 over 9. What about the square root of -121? The square root is an even root. The even root of a negative is not a real number. You can't do it. A positive times a positive is a positive. A negative times a negative is a positive. You cannot take the square root and get a negative number. So this is not a real number. Okay? Now that's a lot to write out. So one thing that I would like or accept here is narn, right? Narn, that's, not a real number, right? So narn. You can also say, so that's what could go here, narn. You could put unreal, not real, it ain't real. Anything that tells me it's not real. It's not real. The next one is the cube root of p to the 51st power, v to the 21st power, c to the 9th power. So again, with powers, you say how many times will this index go into 51, because it's like a fraction, 51 over 3, like this 1/2 became the square root. Here's your 2, here's your 1. That's where you get the 1/2 from. So it's the same idea, just in reverse here. So you have the cube root of p to the 51st. So that's going to be p to the 51 over 3. Well, how many times does 3 go into 51? Well, 51 divided by 3 is 17. V. So what do you do with V? You take 21 and you divide it by 3. 21 divided by 3 is 7. And then C, you have 9. So C to the 9 divided by 3 is 3. P to the 17, V to the 7th, C to the 3rd. And then the next one, the cube root of 125, x to the 33rd power, y to the 18th power. Same deal, except we have a number, a coefficient right here. So then we take the cube root of 125. That is 5. Then we take the cube root of x to the 33rd. That's 33 divided by 3 is x to the what? 11. and y to the 6, because 18 divided by 3 is 6. And in both these problems that I just did, the one in the pink over here on the left and the blue on the right there, there's not a leftover. There's no leftover here. So when we got this, we got 5. There was nothing left over out of the 125 to stay under the radical. We got exactly 11 when we divided 33 by 3. There's no remainder to be a leftover. Same thing here. We got exactly 6. Nothing left over. So anytime I do work outside the box, I circle it. I put my answers in the answer box, because your test is going to look very similar with answer boxes. So you put your answers in the answer boxes. You will use a pencil on a test, pencils only. What about the square root of 225 m squared n to the 24th p to the 30th? Well, again, 225 is a perfect square. That's going to be what? 15. 15 squared is 225. And then m, you say 2 goes into 2 one time with none left over, no remainder. Okay? 2 then goes into 24, right? Into the 24th. 12 times. 24 divided by 2 is 12 again. There's nothing left over, nothing under the radical. And then 2 goes into 30 for p 15 times, and again, nothing left over. So then there's your final answer, 15 m into the 12th, p to the 15th. Then we get the square root of 48 x to the 17 over y to the 10th. Is 48 a perfect square? That's right, it's not. So what's the biggest perfect square that goes into 48? And remember, your perfect squares are 4, 9, 16, 25, 36, 49, and so on, right? 2 squared is 4, 3 squared is 9, 4 squared is 16. That's how I'm getting those, right? Squaring each number. So does 4 go into 48? You say, yeah, 4 times 12 is 48. Well, is 4 the biggest one? Well, look at 12. 12 is 4 times 3, so there's another one in 12. That means there's something bigger than 4 that will divide into this that's a perfect square. I go to 9. 9 won't go into 48. What about 16? Bingo. 48 is what? 16 times 3. So I underline what I'm going to bring out. The square root of 16 becomes what? 4. That's this one here, right? And then what's left under the square root? The 3. That's this 3 here, right? And then x to the 17th. So I take this understood 2 right here and I divide it into 17. I say, how many times will 2 go into 17? Well, that looks like 8. 8 times 2 is what? 16. So there's 1 left over. That 1 goes under here. That's x to the first. This is like 8 times 2 right here gives you 16. And then plus the 1 right here gives you the 17. Okay? So then what about y's? 2. 2 goes into 10. 5 times, and there's none left over, right? So it's exactly 5 y to the 5th. So 4x to the 8th, y to the 5th, the square root of 3x. There's nothing else we can do to this. That's our final answer. 4x to the 8th, y to the 5th, times the square root of 3x. How about the cube root of 27x to the 17th, y to the 8th? The cube root of 27 is 3. 3 times 3 is 9, times 3 is 27. You don't have to break that up like 48. That's a perfect cube. It's just 3. Does 3 go into 17? Not perfectly, right? But it goes into it 5 times because 3 times 5 is 15, right? And 15 is less than 17. But that leaves how many left over? That's right, 2. So this is important. This is a cube root. You got to put the cube root here. That's one of the most missed things on this in any level of algebra is leaving that cube root off. So then this is going to be x squared. We said there was 2 of them, right? This 5 times 3 is 15. That's 15 of them. And then plus the 2 gives you the 17, right? Oops, that's not what I want to do. All right, what about y's? 3 goes into 8 how many times? 2 times. That takes care of 6 of them. And again, there's 2 left over. So 3x to the 5th y squared times the cube root of x squared y squared. So 3x to the 5th y squared times the cube root of x squared y squared. What about 33 square roots of CD minus 6 square roots of CD? Are they like terms? Sure they are. Square root of CD and square root of CD, which means in my answer I'm going to have square roots of CD. And then I just have 33 minus 6, which happens to be 27. 27 square roots of CD here. What about the one beside it? 4 times the square root of 48 equals, I'm sorry, not equals, minus 2 times the square root of 12 plus 7 times the square root of 75. These are not like terms. This, and this are not the same. Like terms have to be the same variables and same powers of variables, but also the same radicals. If the radicals are not the same, they're not considered like terms. So can I break 48 up? Well, you know what? I've already seen that, right? That was already 16 times 3 earlier. So out front, this 4 stays out front. Then this comes out as what? A 4. And the reason I put it in parentheses is these things are being multiplied, right? 4 written beside this is multiply. So then I'm going to multiply that 4 that's out front times the 4 that comes out of the square root of 16. And what's left under the radical? That's the 3 there, right? Now, before I go to the other two terms, the one with the square root of 12 and the one with the square root of 75, let's go ahead and finish this term here. And by finish it, I mean, what else can I do to simplify this? How about put those together? What is 4 times 4? 16 square roots of 3, right? So that term is now simplified. So let's go to the next term. The next term is minus 2. That's this thing coming down, right? How can I break up 12 in a perfect square? Does 6 times 2 help me? That's right. No, it does not help me because the square root of 6 and the square root of 2 are not something I can do. But I can do 4 times 3 because the square root of 4 is 2. So this is going to break up into 4 times 3. So then you have a minus 2. That's this one. Then you have times 2. That's this 4 coming out. It doesn't always have to be 4 and 4 and 2 and 2, y'all. That's just the way the author made this up, or the way I made this problem up since this review. I think I took it from the book, though. Square root of 3. That's this 3 here. Again, let's finish this term up by multiplying these together, and that gives you what? Minus 4 square roots of 3. And finally, we have one more term over here. This one, 75. Can I break that up into a perfect square times something else? 4 doesn't work. 9, no. 16, no. 25, aha. 75 is 25 times 3. So then I have my plus 7, right? That's this. Then I have times the 5. That's this. And then the square root of what? 3. That's this thing here, right? But wait a minute. Again, I can simplify that. What is plus 7 times 5? That's plus 35 square roots of 3. Now, do I have like terms? Well, guess what? Square root of 3, square root of 3, square root of 3. There's no other variables or radicals and stuff, so those are like terms, all 3 of them. So I'm going to put the first 2 together. What is 16 minus 4? 12 square roots of 3, and then add 35 square root of 3. And when I do that, again, those are like terms because of this and this. So that's going to be 47 because 12 plus 35 is 47. Square roots of 3. 47 square roots of 3. So 98x to the 26th, y to the 13th over 2x, 10 to the 7th, y, I'm sorry, x to the 10th, y to the 7th. I said 10 to the 7th. I was reading the exponents. So let's look at this here. This is a radical over a radical, so what we can do is we can put it all together under the same radical. 98x to the 26th, y to the 13th over 2x to the 10, y to the 7th. Well, what is 98 divided by 2? Does that simplify? It does, doesn't it? 98 divided by 2 is what? 49. So this becomes 49. And what about x to the 26th over x to the 10th? What do you do here? You do x to the 26 minus 10. You subtract those, right? So that's going to be x to the what? 16. And then y to the 13 minus 7 is 6. But wait a minute. Have I done this square root right here? Have I done this square root? Nope. Have not. So I got to keep the square root on top. I've got to keep the square root over everything. Is 49 a perfect square? Well, sure it is. And remember, if this was a plus right here, you couldn't do what we're doing, but because it's all multiplied, we can do this individually. So the square root of 49 is 7. And again, we do x to the 16. 16 divided by 2 is x to the 8th. It's tempting to put 4 there because the square root of 16 is 4, but you're dividing the 16 by the 2. So it's 16 over 2 is x to the 8th, and then y to the 6 over 2 because you're dividing by this 2, right? 6 over 2 is going to be y to the 3rd. So it's going to be 7x to the 8th, y to the 3rd. 7x to the 8th, y to the 3rd. And then we come to rationalize the denominator. And if you notice, I put the more difficult one first here. 11 over the square root of x minus 8. If you recall, we multiply this by the conjugate. The square root of x and 8 are both in there, except this time, instead of it being minus, it's going to be what? Plus. And then I like to leave the numerator factored here just in case something divides out. So put this in parentheses. So 11 times that entire thing. Over, now remember, the reason we did this is so when we FOIL it, we get the square root of x times the square root of x. What does that give us? Just x. Then we have this times this, and we have this one times this one. That gives me plus 8 square roots of x minus 8 square roots of x. Those things cancel. I'm not even going to write them down. And then we get minus 8 times plus 8. A negative times a positive is negative. 8 times 8 is 64. I can't simplify the denominator. This answer right here is great for me. But some of you will distribute the 11, and you'll get, so I'll even take this answer. 11 square root of x plus 88 over x minus 64. That's another version of the answer that I'll accept. So, but I'm going to write it in here like this. 11 square root of x plus 8, and that's in parentheses, everything with the 11 over x minus 64. And then 11 over the square root of 3. We're going to take this and multiply just by the radical in the bottom. Square root of 3 over the square root of 3. The denominator is fancy word for the bottom, right? This is where the square root of 3 is. So this is going to be 11 square roots of 3 over square root of 3 times square root of 3 is just 3. And then what we do is we check to see if those things have anything in common. They don't. So then that's my final answer. 11 square roots of 3 divided by or over 3. Now we get to factor completely. We have how many terms here? We have 4. 4 terms. There's 2 things you ask yourself right now. Is there a GCF or does it group? If it doesn't do those 2 things right now, we don't know how to do it, so we put non-factorable, but later this semester we're going to learn how to do that when it doesn't group. But lucky for us, this one is going to group. I'm going to put the first 2 terms together, and what do they have in common? Well, 15 and 10 have a 5, and then H and W have nothing in common, so just 5 is the only thing I can take out of the first 2 terms. If I take a 5 out, that leaves me with 3H minus 2W. That's good. So then what's next? I'm going to try these 2 terms, and notice I include this sign with this term because all that goes together. All right? So then what do 9 and 6 have in common? They have a 3, and you have to have a sign here. You got to have something plus or minus right here. So what you typically do is take this one and put it here. It doesn't always work, but just try that. So we're going to put a plus right there. 3 comes out, and then also both terms have a what? A V. So let's take that V out. And that leaves me with what? 3H minus 2W. Now, is that good or bad? I think that's good because what do you have here? 3H minus 2W, and what do you have here? 3H minus 2W. And the reason I keep going is I know I'm not done factoring because of this. That is not in parentheses. Therefore, it is not factored completely yet. All right? So the things I have underlined in red are they're like factors, common factors. So what do we do with common factor? Just like what do we do with this 5? We brought it out front. What do we do with the 3V? Brought it out front. Here, this and this are both coming out front because they're like terms. And then what's left over? Well, in the blue I have what? 5. And in the green, the lime green here, I have plus 3V, right? That's what's left over here. That's what's left over there once you take this out, right? And it doesn't get crossed out. I was just saying I wrote this down here so I don't write it down again. That's why I crossed that out just there to show you that. So then there's your final answer. It's completely factored. This is in parentheses, right? This one is inside parentheses right here, right? So then 3h minus 2v. And then 5 plus 3v. And here we have two terms on the next one. So it's either GCF. So is there a common factor here? Nope. It's difference of squares. Well, first of all, this is a sum, not a difference, so it ain't difference of squares. You ain't got to worry about the rest of it. And then is it sum or difference of cubes, which is SOPs. And this looks like cubes to me. What do you cube to get 216? So what we're going to do is we got to get the setup, and then we move to SOPPS. Okay? The setup is going to be 6y, because 6 times 6 is 36, times another 6 is 216. 6y plus 5 times 5 is 25, times another 5 is 125, so 6y plus 5. And once we get it set up, then we go SOPs. This stands for square. This S stands for square. Square what? Square the first thing here, right? So that S. So this is going to be 6y in parentheses squared, which means 36y squared, because 6 times 6 is 36, and y times y is y squared. Opposite sign. The only sign I've dealt with so far has been a plus. So what's the opposite sign there? Right, a minus. And then the P stands for product. You take the 6y and you multiply it by the 5, and you don't worry about pluses or minuses there. You just multiply those together. 6y times 5 is what? 30y. And then always a plus here for the second P. And then 5 squared is what? 25. 25. And remember, if you've done everything else before you get to this point, then when you do SOPs, you are done. It will not go any further. Will not go any further. How many terms? 3 terms, right? 3 terms. Is there a GCF? Nope, nothing in common. Is there a 1 in the front? Yes, right? 1x squared. There's a 1 right there, right? So that makes it easier. You look for the factors of 28 that subtract to give you 11, okay? So what multiplies to give you 28 and subtracts to give you 11? Let's see, 1 and 28, 2 and 14, 3 doesn't go into 28, 4 and 7, and that's it, y'all. 4 plus 7 is 11, but what do I want? I want subtract. What is 14 minus 2? 12. 28 minus 1 is, so guess what? There are no factors of 28 that subtract to give me 11, so this one does not factor. We put non-factorable NF. Ain't going to factor. So what about the bomb here? 6x squared minus 19x plus 15. There's 3 terms. Is there a common factor? Nope. I kind of hoped there was a 6, but there's not. And then, has it got a 1 in the front? No, it's got this. 6x squared. The 6 tells you that you have to do what? Bottoms up. So then I'm going to take the 6 times the 15. I get x squared minus 19x plus 90. And so again, I'm going to put this in a thought cloud. Should have drawn that thought cloud first, because this is not equal to what I started with, right? This is not equal to this. That's okay. It's still the way to solve this is bottoms up, a way to do it. Are there factors now of 90? Are there factors now of 90, right here, 90, that add 19? Well, how about 10 and 9? So we got x and 10 and x and 9. Let me fix that. X and 10 and x and 9. Because 10 times 9 is 90, 10 plus 9 is 19. This says they're both negative, right? Both negative. So both negative. X minus 10, x minus 9. And I should not have circled that. Why should I not have circled that? Because it's in my thought cloud, okay? And I'm not done. I need to then go back. Because I multiplied by this 6, I got to do what? Divide by the 6, right? Divide by the 6. So what does 10 over 6 become? Well, it divides out by 2, so it's going to be a 5 over 3 We bring the 3 up front. Here, this is going to divide by 3. This is going to be 3 over 2. Bring the 2 up front. So we get 3x minus 5. And that is times what? 2x minus 3. Now I can circle my answer safely, right? And one thing I need to do is put my answers where? In my answer boxes, right? 3x minus 5 times 2x plus 3. Go back to what can round do for you, non-factorable. And you can write it all out if you want to. What about n squared plus 49? It's 2 terms. Is there a GCF? No GCF. Is it difference of squares? Well, this is a perfect square. That's 7 squared. This even power, right? Even. But then this is what? A plus. That must be minus for difference of squares. Okay? Must be a minus for difference of squares. So that means this thing ain't going to factor. Non-factorable. Sum of squares won't factor. The sum of perfect squares will not factor. So then we get to the scissors here. D squared minus 14D plus 40. There's 3 terms. There's no GCF. There's a 1 in the front. So I want to find the factors of 40 that add to give me 14. So I need to multiply to give me 40 and add to give me 14. How about 10 and 4? So we've got a D and a 10 and a D and a 4. And here, this says both negative. Both negative. All right? So they're both negative. And that one is now done. D minus 10, D minus 4. And then we have the last few here. This one is multiplied. This is just like that last section, P6. You have to divide. When you multiply fractions, you multiply straight across. Anything in the top, the numerator can divide out with anything in the bottom, the denominator, provided it is factored. And those things are identical, all right? So here, I need to factor it. In fact, I need to factor all 4. So let's do this one in orange. There's your good old difference of squares, right? 2 terms, no GCF, perfect square, even power, minus. So this is going to be what? X plus 3 and X minus 3. And then underneath it, we have x squared minus x minus 6, which is x and 3 and x and 2. And how did I get that? Because the factors of 6 that subtract to give me 1. It's going to be 3 and 2, or 2 and 3. And then bigger number gets a negative. So 3 is bigger, gets a negative. 2 gets a positive. And then we move on to the next one. This one right here. Again, 3 terms, no GCF. 1 in the front, so we have x and x. Factors of 14 that subtract to give me to give me 5. I'm sorry, that subtract to give me 5. That'd be 7 and 2, right? 7 times 2 is 14. 7 minus 2 is 5. But I want a negative 5, so that means my bigger number. This says the bigger number has to be what? Negative. The bigger number has to be negative. So 7 is negative, 2 is positive. And then finally in the nice bright green here, it's going to be what? X and X. And I want the factors of 15 that add to give me 8. Well, that's 3 and 5. And they're both what? Positive. Both positive. So now we play our little do I stay or do I go game, or does it stay or does it go? Right? X plus 3 is gone, right? X minus 3 is gone. X minus 7 stays. What about X plus 2? It's gone, so I'm left with x minus 7 over x plus 5. So the smiley face is the same thing as the problem before, except it's got the division. So that means this is going to be keep, change, and flip. So keep this one. Times. Now we move the x squared term, expression, up here, and the 6x plus 24 down here. Now it becomes the problem before it, where I'm going to factor this. So that's going to be what? X and x, factors of 35 that subtract, give me 2. 7 times 5 is 35. 7 minus 5 is 2. And then the 7 is bigger, so it needs to be whatever this sign is right here. So, right, that's going to be minus 7 and then plus 5. The one underneath it, x squared minus 49. Hopefully you immediately recognize that as difference of squares. X plus 7, x minus 7. And then in yellow, we're going to do this one over here. Factors of 21 that subtract to give me 4. Well, that's 7 and 3, right? So x and 7 and x and 3. The signs are different. This time the bigger number 7 gets a plus sign. This is plus 3 gets a minus. So then we have this one here, 6x plus 24. You can take a 6 out and what's left? X plus 4. And again, we say, does it stay or does it go? X minus 7 is gone. X plus 5 stays. X plus 7 is gone. And x minus 3 stays. So we're left with a whole bunch here. We're left with x plus 5 times x minus 3 over 6 times x plus 4, because that's left over down there, right? Nothing here divides out, so that should be our final answer. Then when we add and subtract, we got to get common denominators. If we look at this first one here, x squared plus x minus 12 right here, x squared plus x minus 12 right here. So this LCD is already there, x squared plus x minus 12. So then I just say 8x minus 9 minus, and I'm going to put this in parentheses because if we try to distribute, a lot of times we'll mess up on that second term especially. Okay? So when I do this, this is still all going to be over my LCD, which is x squared plus x minus 12. And then I take and distribute my negative. So this is going to be 8x minus 9 minus 7x plus 19 over the common denominator. And we'll put these like terms together. Right, I have this and this go together and this go together. So 8x minus 7x is x plus 10 over, now look, I can look at x plus 10 and know that there's nothing else I can do. I can't factor it, I can't simplify it, I can't do anything to that. So that means I'm going to go ahead and jump ahead and I'm going to say, look, since this can't anything else happen, I need to factor this down here because my last two steps, remember, are to factor and divide out. So then can I factor this? The factors of 12 that subtract to give me 1. Okay? What do you think? That's right, 3 and 4. So we're going to say x and 3 and x and 4. What about the signs? Bigger number gets a positive, right? Bigger number gets a positive. So 4 gets a positive, 3 gets a minus. And x plus 10 can't divide out and it can't simplify anymore, so that's it. So here, 4 over x plus 2 plus x plus 3 over x squared minus 7x minus 18. Those are not alike. right? Those denominators, this denominator is not the same as this one, right? So then my LCD, right, I got to factor both of them. Well, I can't do anything to this right here. So that's just going to go over here and be part of my LCD, x plus 2. And then here I need to factor this one, x and x. And I want the factors of 16 that subtract to give me 7. I'm sorry, 18. The factors of 18 that subtract to give me 7. I said the wrong number. That would be 9 times 2, right? And 9 minus 2 is 18. Now the signs are different. The bigger number, 9, gets this number right here, so it's negative. And then 2 gets a positive. So this leaves me with 4 over x plus 2. And by the way, my LCD has to have an x minus 9 added to it, right? So x plus 2 times x minus 9. So this needs to be multiplied by something because this is not the same as that. When that's the case, you got to multiply by something. And then you have plus x plus 3 over what? My common denominator already. No, I'm sorry, over this denominator, which happens to already be this, right? So it doesn't get multiplied by anything. Over here, I have to put this in here. It's going to be x minus 9. So this is going to end up being 4 times x minus 9 plus x plus 3 over x plus 2, x minus 9, or other way around, however. And then I need to simplify. So you got plus signs up here that are not in parentheses. You're not ready to start crossing stuff out or anything. You got to distribute the 4. And that's going to give you 4x minus 36 and then plus x plus 3. And then x plus 2 and x minus 9. You just fix that 9. So then, let's see, something's going to happen here. This and this go together, and that gives you 5x. And then this and this go together, and it gives you minus 33. Hope I did that right, because I don't remember that number, but maybe that's it. X plus 2 over x minus 9. Sorry, x plus 2 times x minus 9 is all over that. 5x minus 33. And 5x minus 33 won't simplify, it won't factor, so and it won't cross out with anything in the denominator, it won't divide out. So you know what? You're done with the problem. That's it. That's it. So what I would do is circle this answer, and then, of course, write it in the answer blank like I just did there. All right? So that's been your review for College Algebra Test 1. Good luck, and may the force be with you.